Alright, so we'll complete the rest of the topics from the last session. So the next topic is queues. So just as we explored the use of stacks for managing elements in the last in first out manner, queues offer a structured way to handle collections of elements following a first in first out model. This means that the first element added to the queue is the first one to be accessed or removed, making queues ideal for scenarios where order of operations or events matter significantly, such as in task scheduling or managing lineups. So, what is a queue? We discussed in the last session. A queue is a dynamic collection that allows elements to be added to the end and removed from the front. So the first in first approach is opposite to how stacks operate and is critical in situations where fairness or uh, chronological order is needed. So some of the characteristics of queues are variable length and also a support for nulls or duplicates. So variable length, when it comes to variable length, like stacks, the size of the queue can increase or decrease dynamically as elements are added or removed. So queues can store again. Other one is support for nulls or duplicates. So queues can store null and duplicate values, which can be useful depending on the application requirements. So yeah, so the syntax to declare. So the syntax to declare a queue in C sharp is straightforward and involves specifying the type of elements it will hold using generics for type safety. So this declaration creates a new uh, queue of a specific element type, which is denoted by element type, and with a name being a unique identifier for the queue. So to declare a queue of strings, uh, you could write something like a queue element type is string name, something like, excuse me, my queue. New queue element type is again string. So yeah, this is an example for queue of strings. And C Sharp also provides a non-generic version of a queue, uh, similar to the stack. So this version does not require specifying the type of elements it holds, which can lead to type safety issues and is generally less efficient. So the use of non-generic collections is discouraged in favor of generic versions that ensure type correctness and better performance. So once a queue is declared, you can perform various operations to manage its contents effectively. Uh, like for example, first is adding elements, which is Enqueue. So uh, so you can add with Enqueue, you can add elements to a queue using the Enqueue method, which inserts uh, basically an element to the end of the queue. Let me pull up an example for that. Yeah. So yeah, this is an example to basically add insert element at the end of the queue. Harrison, then Alex, then Haley. um, and removing elements is done by Dequeue. So um elements are removed from the front of the queue using the Dequeue method. This method also returns the removed element, like string item is equal to my queue dot Dequeue. Yeah, this is an example for Dequeue, and we have peaking. To look at the elements at the front of the queue without removing it, you can use the peek method. uh, like if we could, example is my queue dot peak. It's a simple, but yeah, it's so queues in C sharp provides a robust mechanism for managing collections where the order of entry is crucial. They are extensively used in programming scenarios that require processing elements in the order they arrive, such as handling requests on a server, managing print jobs, or implementing breadth first search algorithms in a graph based problems. So understanding how to declare, populate, and manipulate queues is essential for developing applications where order specific processing is required. So that's about queues. Yeah, we're gonna discuss more about adding DQ, NQ, peak. So in this section, we're focusing on practical operations for managing queues in C sharp. So as I mentioned, a queue is structured to follow first in first out principle. It's particularly effective for tasks where order of elements matter, such as managing a lineup of players or tasks. So let's discuss how to create and manipulate and access elements in the queue using examples of managing active players in a game. So to start working with queues, first you need to create an instance of Qt. So this one. So T is a type of elements the queue will hold. Will use string as the type to hold names of the players. Uh, Let me remove all this. Yeah, yeah. This line initializes a new queue called activePlayers that will store strings. Each string in this queue represents the name of a player who is currently active in the game session, and Enqueue operation. So adding let me pull up the example. So adding elements to a queue is done through Enqueue, as I mentioned. Enqueue method. This method appends new element to the end of the queue. So in this examples, we have three players: Harrison, Alex, and Haley, were added to the queue in sequence. So according to the first in first out nature of sequences, Harrison will be the first player to be served, followed by Alex and then Haley. So next is accessing elements. To look at the first element without removing it from a queue, you use the peek method. So this is useful when you need to know who is next up without modifying the queue. Uh, Let me put the code. Yeah, so this code retrieves the name of the first player, which is Harrison, and stores it in the first player. But Harrison remains at the front of the queue. And we have DQ operation, which when you need to remove the first element from the queue, effectively serving or processing that player, you use the DQ method. Uh, So this line, executing this code will remove Harrison from the queue and return his name, updating the state of the queue so that Alex now becomes the first player in the line. So with these basic operations, Enqueue, peak, Dequeue, you can effectively manage a dynamic list of elements in a system that requires orderly processing. So this setup is ideal for scenarios such as managing player turns in games, ticketing systems where first ticket issued is the first served, or processing tasks in computing environments where the order of execution is crucial. So while this introduction covers the essential functionalities of queues, the Qt uh, class in C Sharp also offers other methods and properties that can handle more complex scenarios and provide additional control over the queue's elements. So exploring these advanced features can provide uh, deeper insights into queue management and its application in more sophisticated systems. Uh, So it's important to note that these data structures, while serving different organizational functions like first in first out for queues, last in first out for stacks, share a similar set of operational methods. So this similarity underscores the fundamental aspects of C Sharp collections, providing a unified approach to manipulating different types of data collections. Uh, so yeah, queues and stacks both being part of system dot collections dot generic namespace offer a standard set of methods that facilitate the management of their elements effectively, like adding elements. So for queues, elements are added using enqueue method, which inserts items at the end of the collection. For stacks, the push method adds items to the top. When it comes to removing items, items are removed from queues with dequeue method, which is removing the oldest element, and for stacks with the pop method, removing the newest element. Peaking, both structures allow you to peak at the next element to be removed, which is using the peak method without actually removing it. Uh, Providing a way to insert the next item in line. We have clear. The clear method empties the collection completely, resetting its state and content. um, and the we have contains method, which lets you check whether a specific element exists within the collection, which is useful for validation before operations. We have copy to method, which transfers elements into external array, starting at the specified index, which is useful for integrating with non-generic data handling processes. So these methods are crucial for maintaining control over the elements within these collections, so ensuring that data can be managed in a predictable and orderly fashion. So for you, for if you're seeking to understand the full range of capabilities of these collections, the Microsoft documentation provides a comprehensive details on each method and property available for queues and stacks. So it's invaluable for both beginner or experienced developers, as it not only lists methods but also provides usage examples and context for when different methods might be most applicable. Now next is HashSet. So having established a good understanding of queues and stacks, so the next logical step is exploring C sharp collection types. uh, is the is to examine the hash set. So unlike queues and stacks, which are linear data structures, hash set is designed to handle unique elements and supports a variety of mathematical set operations effectively. So these operations such as union, intersection, difference are crucial in scenarios where you need to perform bulk operations on groups of items without duplication. So this makes HashSet particularly suited for tasks that involve large data sets and require performance optimized operations for checking membership, adding and removing items. So by familiarizing yourself with these various collection types and their operations, you can better choose the right tool for your specific programming challenges, which enhances both efficiency and readability of your code. So HashSets. So HashSets in C Sharp represents a fundamental shift from a sequentially ordered collections like queues and stacks to a more sophisticated structure uh, designed for unique item storage and rapid operations. So understanding how to utilize HashSets effectively can greatly enhance performance in scenarios where checking for duplicates and maintaining unique elements are crucial are critical. So what is a hash set? A hash set is a collection that stores elements in an unordered manner but ensures that all elements are unique. This means that no two elements in the hash set can be same, which is similar to the keys in dictionary. However, unlike a dictionary, a hash set only stores individual values, not key value pairs. Uh, so let me So a hash set is declared by specifying the type of elements it will contain within a angle brackets. Here is a basic syntax for declaring a hash set. So here element type is the type of elements the hash set will store. Again, name is the variable name you assign to the hash set. So unlike queues and stacks, you can initialize a hash set with elements right at the point of declaration, which pre-populates the hash set with the initial values. Let me so Yeah. So this code creates a hash set of strings with three names. If any duplicates are included in the initialization list, they will automatically uh, be ignored. And next, adding. The add method attempts to add an element to the hash set. If the element is already present, the method will not add it again, thereby preventing a duplicates and maintaining the uniqueness of elements within the hash set. Um, Next is removing. Similarly, you to remove an element, you'll use the remove method. Uh, yeah. So this method removes the specified element if it exists in hash set, and returns a boolean indicating whether the operation was successful uh, or unsuccessful. So hash sets are particularly valuable in scenarios where you need to quickly check for the presence of an item or items without duplication, or perform set based operations like union, intersection and difference. So the underlying implementation of hash sets uses a hash table which ensures that adding elements, checking for their presence and removing elements are all operations that can be performed in constant time on average. And we have set operations where HashSets truly excel is in their ability to perform complex set operations efficiently. So these operations allow you to compare sets and derive new sets based on the presence or absence of elements. So these operations are highly optimized and provide a powerful tool for handling large data sets, where operations like intersection is finding common items between two sets, or difference is basically finding items present in one set but not the other, which are frequently used. So HashSets offer a robust method for managing collections where uniqueness of elements is important. So they are essential tool in for programmers, essentially suited to applications involving large data sets with operations that require frequent membership checks and set manipulations. So this makes them an excellent choice for applications in data analysis, statistical computations, and wherever data integrity and performance are important. So uh, yeah, we'll discuss more about set operations. So in this section we'll discuss more about set operations, which is a powerful feature of HashSets in C sharp, which enables the performance of complex mathematical operations on sets effectively. So understanding these operations is crucial for managing collections where operations involving multiple data sets are frequent and require high performance. So set operations in C sharp allow you to manipulate the contents of hash set based on its relationship with another hash set. So the operations modify the hash set on which they are called, which are referred as current set. Um uh, which using the elements of the specified set passed as a parameter, as a method parameter. So let me pull up an example. Yeah, so this syntax shows the set operations are methods called on the current set, which is the calling hash set, which then takes another hash set, which is specified set, as the parameter. Uh, Here we have different key set operations. We have union with, intersect with, and except with. We'll discuss each of these. Union with is the purpose of union with. Let me actually. Yeah, so the purpose of union with is it combines the elements of both current set and specified set into the current set. So if there are any duplicate across the sets, they will be included only once due to the inherent properties of the hash set. Uh, Example, let me. Yeah, so the active players example. So this is useful when you need to gather all unique elements from two different collections, such as combining active and inactive players uh, into a single list. So after the operation, active players might contain Harrison, Alex, Haley, uh, Kelsey, Basil, which are so Kelsey and Basil came from a different set. So yeah, uh, that's what union with does. Next we have intersect with, which the purpose of intersect with is it modifies the current set uh, to include only elements that are also found in the specified set. This operation is particularly useful for finding common elements between two sets. Um, Let me remove this. Intersect. So we have a premium players set here. Uh, we are basically identifying players who are both active and premium members. So after this operation, active players would only contain uh, Haley, assuming that she's only overlap between two sets. Uh, Next, we have except with. The purpose is it removes all elements in specified set from current set. This is used to filter out elements from a set that are not desired. Uh, so finding active players who are not premium members. Uh, Let me pull up the example. Just, yeah. So yeah, if you're finding active players who are not premium players, so after this operation, the active players would exclude Haley, uh, retaining Harrison and Alex. So each operation directly modifies the current set, which means the original collection changes with each method call. So this aspect is crucial when performing multiple operations sequentially, as each operation's result impacts the next unless new instances or copies of the original sets are used. So the ability to perform these set operations effectively makes HashSet an invaluable tool in scenarios requiring operations on large data sets, where performance and integrity of data manipulations are priorities. So these operations facilitate complex data relationships and analysis, such as finding overlaps, exclusions, or combinations in data-centric applications. Uh, so by understanding these set operations, you can significantly enhance the data handling capabilities of your applications, making them more efficient and capable of performing complex data manipulations with ease. Uh, so as we wrap up this topic, let's take a moment to recap the powerful collection types you have learned about and how they can effectively used in different programming scenarios. So this knowledge uh, will be a great benefit for you, enabling you to choose the most suitable data structure based on the specific needs of your application. So we discussed about stacks. Stacks are ideal when you need to manage data in a reverse order from how it was initially added. This is often referred as last in first out approach. So stacks are particularly useful in scenarios such as undo mechanisms in text editors or browsers, where the most recent action should be reversible first. Queues, in contrast to stacks, queues manage data in first in first out order, meaning the first element added is the first one to be accessed or removed. This makes queues perfect for situations like customer service systems or task scheduling, where the order of arrival or addition must dictate the order of handling. Um, Hasset are specialized to handle unique specialized to handle unique elements without any duplicates. They are not ordered, which allows for very efficient addition, removal, and especially lookup operations. So Hasset shine in scenarios where you need to perform quick checks against the dataset to see if an item exists, manipulate large data sets of large data set using set operations like unions and intersections, or simply when ensuring that no duplicates are present, such as user roles or permissions management. So each collection type supports specific methods that allow you to manipulate and access the data effectively. Stacks utilize push, pop, peek operations to add, remove, and view the top element. Queues use Enqueue, Dequeue, and peek to add to the back, remove from the front, and view the first element. HashSet offers operations like add, remove, and set specific operations such as unique, union with, intersect with, except with, to manage elements based on mathematical set principles. The mathematical operations available with HashSets allow for sophisticated data manipulations, like for union with combines two sets, keeping only unique elements. Intersect with finds common elements between two sets. Except with removes elements of one set from another. So these operations are important for handling complex data relationships effectively, and are an example showing the power of using right data structures in programming. So as we progress into the next topic, you'll we'll go deeper into intermediate C sharp concepts like delegates, generics. So these tools will further enhance your ability to write efficient and reusable and flexible code. Uh, so C sharp is a vast and full of uh, opportunities to refine your programming skills. Uh, Remember that each topic is not just an end, but a stepping stone to more advanced concepts and greater challenges. So, understanding and choosing the appropriate collection type and understanding their operations can drastically improve the performance and capabilities of your applications or games. So, this topic uh, has given the knowledge to make these decisions effectively, setting the stage for even more advanced programming techniques ahead. That's the end of this topic.